In less than 3 days, a high-security truck will arrive to transport the gold to the Perth Mint. The countdown clock is ticking, and Dale's team still have 4 critical challenges to overcome to hit their deadline. While the shovels dig, a fleet of 40 monster trucks hauls the precious quarry to the processing plant. As each 400-ton truck climbs out of the pit, there's a real risk that vibrations could destabilize the walls. Challenge 4, prevent a landslide.
The pit's so big, the challenge we have there is to make sure that it remains safe. We can't have rocks falling, windrows disappearing, berms disappearing. We've got to make it safe for the person who's working down the bottom.
Making sure the pit's 500-metre high walls don't cave in today is Anthony Gleeson.
The height of the walls is our biggest challenge. Any rock falls we have from those heights has the potential to be extremely dangerous to anyone working below.
To inspect the walls, Anthony uses a revolutionary device invented in South Africa. Slope stability radar. It can measure movements in the walls with millimetre precision. Anthony knows that a wall failure here could be disastrous.
Our primary piece of technology for monitoring the walls is the slope stability radars. We deploy them around site where we believe we've got potentially unstable regions, and that provides information and data on how fast the walls are moving and what direction the rock mass is moving, whether there are any areas of instability.
The slope stability radar can sense tiny movements in the pit walls. A dish projects a radar beam which scans the danger zone to build up an accurate 3D picture of the wall. It rescans the wall every 2 minutes, comparing its profile with the original image. If part of the slope moves, even as little as a millimetre, it's a sign that the wall is unstable. The radar picks this up and alerts the mine engineers, giving them plenty of time to evacuate the area. Today, Anthony identifies a section of the pit wall that could put the miners in serious danger.
There's an area on X-ramp that has a potentially unstable slab of rock sitting directly above it. Now that ramp services the bottom of the pit, so we need to ensure that people can drive up and down.
Anthony sends his wall maintenance team to strengthen any weak areas of rock.
To ensure that the rock mass and the walls stay together, we use rock bolts or cable bolts that are drilled into the walls. We also use mesh over broken ground. That helps keep the integrity of the rock mass together in certain areas.
These critical reinforcements stop unstable rocks from falling on the miners working 500 metres below on the pit floor. Disaster averted.
We put a lot of our faith into the radar and the information that it can give to us to make the pit a safer working environment.